Hi there, my name is Miss Townsend and this is Math with Townsend. So this video is part 2 of a video taking up the solution to question 4, and it's for the grade 10 academic students doing their summative. So again, video part 2 of question number 4. So this is where we were. We started off by drawing a particular rhombus called UVWX, and that's what you see here in blue. We then had to find the midpoints algebraically, so we found A, B, C, and D using the midpoint formula. And then we connected those midpoints, and our whole purpose for part B is to prove that this is a rectangle. So we started by reviewing what it meant to be a rectangle. So we knew that there were 5 things we had to do. We had to show that opposite sides are the same length. So we had to show that AB and DC were the same length. So AD and BC. We had to show that oops, I read that backwards. Sorry, we had to show that AB and DC were the same length, so AB and DC. We had to show that AD and BC were the same length. And then we have to show that opposite sides were also parallel. So we have to show that AB is parallel to DC, and that AD is parallel to DC. And then finally, if all we did was this stuff, we would have a parallelogram. And to make sure that that parallelogram is actually a rectangle, we have to make sure that adjacent sides are perpendicular. So that's the math we have to do in part B. And if you watch video number 1, you know that we started here. We started by looking at length. So in video number 1, we calculated the length of some of the sides. Now, I didn't do all of them. Hopefully you took the time between videos maybe to do the math for the rest of them, but you should have discovered that indeed these are the same lengths, and the value we got was 3 root 2 over 2. And here we found that they were 5 root 2 over 2. Now those values that we got, if they look funny to you, maybe it's because your teacher says that decimals are cool. You know, they're fine. So maybe instead you got 2.12 units as the length of ABCD, of AB and DC. And here you would have got that this side length was 3.54, rounded, you know, not exact. These are inexact values. These are exact values. But either way, we have verified algebraically that we have opposite sides that are the same length. So now we need to, in this video, show that opposite sides are parallel. So in other words, that AB is parallel DC and AD is parallel DC. That shouldn't say DC. Let's see. AB has to be parallel DC and AD, so that should be BC. So let me fix that. It's there. Now that clearly says BC, right? Good enough. So how do we show that sides are parallel? Well, we know that parallel is a statement about slope. So from your memory bank, grade 9, you need this formula. The formula for finding the slope of the line that connects 2 points. So let's start with AB. So to find the slope of AB, again, slope is a small case m, and we're going to find the slope of AB. So y2 minus y1 over x2 minus x1. So don't get freaked out because I have a giant fraction here, and then I have a fraction in the numerator and a fraction in the numerator, and suddenly the whole world is just fractions. Take it step by step, piece by piece. Remember, the numerator is sort of like its own separate question, and your denominator is sort of like its own separate question. So by all means, go to the side of your page if you want, and do the math here for the numerator and simplify that as far as you can. And then, you know, don't do it on scrap paper. Do it so your teacher can see what you're doing. But you can probably, if you're neat enough, do it directly inside of the main question. Just make sure that this line here that represents the major fraction is long enough and big enough that it's very clear where the numerator and denominator are. So in the numerator, if I wanted to do subtraction, 2 minus 7 over 2, I need a common denominator. So instead of 2, I'm going to say 4 over 2 minus 7 over 2. Oops. So that's the numerator. Draw a nice big line to represent the major fraction, and let's look at the denominator. So also in the denominator, I have a fraction, negative 5 over 2. Minus and negative, we know that means plus. And I need, again, a common denominator. So my denominator is 2. So this is going to become 8. Okay. So you can see that I'm just kind of treating each question, each side of this fraction as its own little piece of math. Let's look again at just the numerator for a moment. I have denominator 2. 4 take away 7 is negative 3. There's my numerator. Nice big line for the major fraction. In the denominator, over 2, negative 5 plus 8 is just 3. So I have negative 3 over 2 over 3 over 2. So, now, you should know what the answer is already. Just in case, let's do a little brain bubble check over here. If I had the fraction negative 6 over 6, what would that simplify to? Well, it would be negative 1. If fraction negative 18 over 18, what would that simplify to? Negative 1. If I had the fraction negative x over x, that would simplify to negative 1. So that's really what I have here. I have negative something over positive same thing. So negative something over positive same thing is just negative 1. So therefore the slope of AB is negative 1. Okay? So that's the slope of AB. And we need to make sure that that's the same slope as DC. So again, I'm not going to do that in the video. I think that it's important that you maybe pause here and try it on your own, or at some point you make sure that you're not just watching the video, that you're also doing the math yourself. So make sure, please, that DC also gives you a slope of negative 1. So what I am going to do is let's look at the slope of the other sides. So let's look at AD as a slope, and hopefully it'll simplify itself. Okay. So I need some information here. So let me copy this. Little peek behind the scenes of me figuring out what I want to do next. How's things? Good? Yeah? How's math? Excellent. That's not what I wanted, is it? See, I could press pause, but then you'd miss all this fun stuff. Okay. I want this. So I'm going to not do that. I'm going to copy it down here, and then I'm going to paste it, I hope. Whew. Boy, oh boy. There we go. Hooray! Yay! So, I was finding the slope of side AD. So, you know the slope formula. I'm not going to write it again. It's y2 minus y1. So, y2 minus y1 over x2 minus x1. So, negative 13 over 2 minus negative 4. So again, just like you just saw me doing, we're going to have a nice big fraction line, and we're going to deal with the numerator and denominator as separate little pieces of math. So on the top, I need a common denominator. So 1 becomes 2 over 2, and that'll be minus 7 over 2. On the denominator, so 13 over 2 minus negative is plus, and 4 would become 8 over 2. Good, so keep going. In the numerator, denominator is 2. 2 minus 7 is negative 5. And then nice big fraction line over 2. Negative 13 plus 8. Negative 13 plus 8 is negative 5. So now look what I have. Here's the big fraction. I have negative 5 over 2 over negative 5 over 2. And I'm sure I don't need to tell you this, but let's look anyway. If you had 6 over 6, what would that be? 1. If you had 183 over 183, that would be 1. So anything over itself is just 1. So the slope of AD is just 1. Okay, so I'm not going to go through the steps of finding the slope of the other side. Again, press pause on the video and you do it. But now we know the slopes of all the sides. So the second part of proving that something was a rectangle was to check for parallel lines, and we did that, and we learned that these sides here are both slope equal to negative 1/2, therefore, sorry, -1, therefore they're parallel, and we found that these sides here both have slope of 1. Oh, did I get that backwards? Well, both of these say A, B, D, C. That doesn't make much sense, does it? Just a second. There. What mistake? There was no mistake. It was perfect the whole time. So we found that AD and BC both have slope of 1, so therefore opposite sides are parallel. And there's one more step to go, because if we stopped here, again, we would have proven that we have a parallelogram, but not a rectangle yet. So the final step of showing that we have a rectangle is to show that adjacent sides are perpendicular. So if you remember the little diagram that we had, let's kind of sketch that real quick. Here's my parallelogram, because I can see that for sure now. And it looked something like this. And so now we know for sure that we have parallel sides on opposite sides, and we have sides that are the same length. And now we just have to show that we have perpendicular sides being adjacent. So what does it mean to be perpendicular? Oh, I'm not trying to cross it out. So if two slopes are perpendicular, so if M1 and M2, so that's how you say two slopes, right? If two slopes are perpendicular, and nice shortcut, then what do we know about M1 and M2? So certainly I know a lot of you would say, well, they're negative reciprocals, but in a proof, I mean, in a verify, in a show that, it's really tough to show that without just saying, like, look, see? So the other definition where M1 times M2 equals -1, that's actually how you want to verify or show that two slopes are perpendicular. So the slope of AD, the slope of AD was 1. The slope of AB was -1. And 1 times -1 equals -1. Therefore, AD is perpendicular to AB. So there you go. Those were the 5 things I needed to show. Opposite sides were parallel, opposite sides were the same length, and an adjacent corner was a 90-degree angle. So we verified that that shape was a rectangle. It took 2 videos, but some pretty basic math, just lots and lots of it. So all done this question. I hope that helped. See you in school.